Okay, in the last lesson, we talked about measures of variability. So I'd like you to take a look at the following two questions. The first one is asking you to find the measures of variability, range, interquartile range, variance, and standard deviation for the data set that's listed there. And then number two is asking us to use COVAR to determine which one is more variable. Pause the video here, find those measures, and then unpause the video to get the results. Okay, for these examples, we have found the range is 6, the IQR is 2, the standard deviation was 2.07, and I squared that to find the variance of 4.28. So I did enter these values into the graphing calculator. For COVAR, the standard deviation divided by the mean times 100 for each data set gave me 9.2% for the SAT and 11.9% for the ACT. Since the 11.9 is larger, the ACT is more variable. Okay, today we're going to be discussing empirical rule in the lesson. The empirical rule states when a distribution is bell-shaped, the following statements are true. 68% of the data will fall within one standard deviation of the mean, 95% within two standard deviations of the mean, and 99.7% within three standard deviations of the mean. Here is a visual of what that would look like. So if our mean is in the middle of the distribution, we go one standard deviation out in either direction. That range of values is going to represent 68%. If we go out two standard deviations from the mean in both directions, it's going to represent more of the distribution, 95%. And three standard deviations is just going to about cover the entire distribution at 99.7% of the data. Okay, so taking a look at our first example, we're going to use empirical rule to label this distribution, the mean, and then three standard deviations out in both directions. We're then going to use this distribution to answer some questions. Okay, so let's get started. It says, Americans spend an average of 3 hours or 180 minutes per day online. If the standard deviation is 32 minutes and the distribution is approximately normal, draw and label the distribution. Okay, so if our distribution is symmetrical, that means all of the measures of center are exactly in the middle. So this line that's in the middle of the distribution is going to represent the mean. So I'm going to put that mean right in the middle. Our mean was 3 hours or 180 minutes. I'm then going to move standard deviations in the positive direction. So if I move one standard deviation to the right, our standard deviation is 32 minutes. So I'm going to add 32 minutes to 180. So 180 plus the 32 would give me 212. So this first line that is one standard deviation above the mean is going to represent 212 minutes. I'm going to continue that process. So adding another standard deviation to the mean, or another 32 minutes, I would get 244 minutes. And one more standard deviation out, again adding 32 one more time, would give me 276 minutes. Okay, now we need to do the same thing below the mean. So now I'm going to be subtracting standard deviations from the mean. So if we subtract one standard deviation, subtract off 32 minutes from 180, I would get 148 minutes. Again, I'm going to subtract another standard deviation off. So if I subtract 32 from 148, I would get 116 minutes. And if we subtract one more standard deviation off, again, subtracting 32 from 116, I would get 84 minutes. Okay, so now I see this distribution is normally shaped, centered at 180, and ranges from about 84 to 276 minutes. We're going to use this to find certain percentages of data that fall within regions. Okay, so I've drawn out this distribution, again, labeling those values that we just came up with a minute ago. And we're going to answer the following 8 questions using empirical rule. So the first question says, between 148 and 212, what percent of data falls within that range? All right, so if we notice, 148 is 1 standard deviation below the mean, and 212 is 1 standard deviation above the mean. So empirical rule states that within 1 standard deviation in either direction, that's going to be 68% of the data. So 68% of the data is going to fall in that range from 148 to 212. Number 2, between 116 and 244. We see that that's 2 standard deviations above and below the mean. Empirical rule states that 95% of the data is going to be within 2 standard deviations. Number 3, between 84 and 276. That is 3 standard deviations out in both directions. Again, empirical rule states that that's going to be 99.7% of the data. Now, these next 5 questions, we're going to still use empirical rule, but there's going to be a little bit more work involved with that. So the first question, less than 180. If we find 180, 180 represents the mean of this distribution. But since it's symmetrical, it also would represent the median. Remember that the median cuts the data exactly in half. So that means 50% is going to be on the left and 50% on the right. So less than 180 would be 50% of the data. All right, the next question says between 148 and 244. Okay, notice that 148 is just 1 standard deviation from the mean, whereas 244 is 2 standard deviations from the mean. So let's deal with each of these halves separately. If I think about what empirical rule states that within 1 standard deviation on both sides of the mean will be 68%. But let's just think about this left side. So I'm going to take that 68% and cut it in half since, again, we're just dealing with the left side right now. So half of 68 is going to be 34% of data. Okay, now let's think about the right side. The right side is 2 standard deviations out. So 2 standard deviations out on both sides of the mean is 95%. So again, I'm going to cut that in half. 95% divided by 2 is going to give me this right side of the distribution. Then I would simply add these 2 percentages together. So half of 68 plus half of 95, add those up, and that's going to give me that percentage. Let's see what that is. Okay, I took half of 95, which came out to 47.5% of the data, and then I added those 2 percentages together. So 34% plus the 47.5% gives me 81.5% of data should be contained within that range. Okay. Okay, let me clean this graph up a little bit so we have a little bit more room. Okay, this next question says more than 212. So 212 is just one standard deviation above the mean, but only to the right. So one standard deviation out in both directions is 68%, but I'm going to divide that in half so I know that this portion is 34%. That's not the portion that I want. I want the remaining percent on that right side. So we had said earlier that the right side of the distribution is 50%. So I'm going to subtract those two values. So 50 minus the 34, that's going to leave me 16% of data to fall on that right tail. So more than 212 is going to be 16% of the data. There's also other ways that you could do that. Okay, let's take a look at less than 116. I'm going to change colors here. Less than 116. 116 falls on the left side of the mean, and notice that it's 2 standard deviations away. So I'm going to again think about just this portion. 2 standard deviations out in both directions is 95. And if we cut 95 in half, we found earlier that that was 47.5%. Again, all on the left side is 50%. So thinking about what remains, 50% minus the 47.5%, that's going to leave me 2.5% of the data is going to fall in that left tail. All right, last question is more than 148. I'm going to switch colors one more time. Let's go with some green. More than 148. 148 is 1 standard deviation below the mean. Okay, so thinking about what percent that would be, 1 standard deviation out in both directions is again 68, but I'm only moving to the left. So this portion is 34%. But I want more than 148. So I actually want from the 148 line all the way up to the right tail. So that's going to be that 34% that we said earlier plus 50% of the data, because we want that whole right side. So if I add those two numbers together, that's going to give me 84% of the data is going to be 148 or more. Okay, taking a look at another example together. This example says a dog lives an average of 13.1 years with a standard deviation of 1.5 years. If the lifespans are normally distributed, draw and label the distribution, then answer the following. Okay, so first of all, we're going to label this distribution. So the average, the mean, is 13.1. So I'm going to put that value in the center. And we're going to add standard deviations to the right and subtract standard deviations to the left. So we're adding 1.5, which is our standard deviation, to that 13.1. So I would get 14.6. If I add it on again, that's going to be 16.1. And adding it on again, I'm going to get 17.6. Okay, subtracting it off from 13.1. Okay, subtracting that 1.5 off, I am going to get 11.6. Subtracting 1.5 off again, I get 10.1. And one more subtraction of 1.5 gives me 8.6. Okay, we're going to use that to answer the following questions. Number 1, what range of values represent the middle 68%? So thinking about empirical rule, 68% corresponds to 1 standard deviation from the mean. So if I go 1 standard deviation in either direction, I am at the ages 11.6 to 14.6. Okay, what age are the oldest 2.5% of dogs? Okay, so I know I'm going to go above the mean because I want the oldest 2.5%. As I move away from the mean, I'm going to think about what is going to be left over in that right tail. So if I just move 1 standard deviation above the mean, that's going to be 34% there in the middle. That's going to leave me 16% for the tail. So that's too high. All right, let's go another standard deviation out. If I move 2 standard deviations out, that's going to be in both directions 95, so half of that is going to be 47.5%. And if I think about what's left over, that's going to do it. 50% minus the 47.5%, that's going to leave me 2.5%. So that was 2 standard deviations, so I'm at 16.1 years. Okay, and then 84% of dogs are younger than what age? Okay, if I want 84% to be younger, then I have to be above the mean for 84% to be to the left of the distribution. Because if I stay here at the mean, there's only 50% of dogs younger than the mean. So I know I have to be to the right of that to get more of a percentage on that left-hand side. So I'm going to, again, just start to add standard deviations and think about what percent would be to the left of that. So at the mean, I have 50% below. 50% is too low. So let's move up 1 standard deviation. We said earlier that that's 34% of the data. So 34% added to that 50%, that's 84. So I just had to move 1 standard deviation up, and 14.6 years or younger is going to represent 84% of dogs. Okay, guys, this next slide is a you-try. So read through the scenario, pause the video, see if you can find those 4 answers, and then unpause the video to get the results. Okay, here are the results of those 4. First of all, I went ahead and labeled the distribution by putting the mean 240 in the middle, and then adding 38 3 times, and subtracting 38 3 times. Answering the question, number 1, between 164 and 316, that's 2 standard deviations in both directions. Empirical rule says that that's 95%. Between 202 and 354, this was a tough one. 202 was only 1 standard deviation to the left. So I took 68 and divided it by 2 to get that percentage. 354 was 3 standard deviations to the right. So I took 99.7% and divided by 2 to get the percentage on the right side. We're going to add those 2 percentages together to get the whole range, which is 83.85%. Less than 278. 278 was 1 standard deviation above the mean. So this area from the mean up to 278 would have been 34%, and I added that to 50% to get that 84%. The last one asks more than 354. 354 was 3 standard deviations above the mean. So 3 standard deviations in both directions is 99.7%. So that leaves 0.3%, but that's for both the right tail and that left tail. So I took the 0.3% that's left over and divided it by 2 to get the 0.15% that would be just on this right tail region. Okay, this concludes empirical rule for today.